Hey champions, Adam here. Tune into the podcast, Intro to Dart for Flutter. Quick and simple. Subscribe and explore.
Welcome to the deep dive. If you're looking for the absolute essentials of a topic, distilled and ready to use, you're definitely in the right place. Our mission today, we're cutting straight to the core of Dart, the programming language that really powers Flutter. So if you want to jump into Flutter development, understand what the code's actually doing, but maybe skip spending months buried in tutorials, well, this deep dive is basically your shortcut. We're zeroing in on the key concepts, the things that really define Dart's syntax and structure.
And that focus is, I think, really important. A lot of developers coming to Flutter worry, do I need to become a Dart expert first?
Yeah.
But what we've seen is that understanding its foundations, especially those safety features, that's what really unlocks productivity in Flutter. If you can read the code comfortably, you can start building pretty much right away.
And here's maybe the key insight, especially if you're coming from, say, Java, JavaScript, or really any C-like language stack. Dart is designed to look familiar. You'll recognize the syntax, the loops, the control flow almost immediately.
Yeah, it's very intentional. They wanted to make it easy to adopt. And just on a practical note, something that saves you a step right at the beginning. When you install Flutter, it automatically installs the Dart SDK, so you don't even have to think about a separate Dart setup. It's just handled.
Okay, perfect. So let's unpack Dart itself. We know it's the engine under Flutter, but what gives it that reputation for reliability and structure? What makes it different from, say, JavaScript running in a browser or maybe Python?
Yep. It really boiled down to safety, primarily type safety. Dart is what we call a type-safe language. And that means it uses static type checking. So the compiler is checking the types of all your variables, all your expressions, before the code even tries to run. The whole goal is predictability. You want to know that a variable's value will always match the type you expect it to have. But what's really clever is how Dart combines this safety with developer speed, using something called type inference. So often, inside a function or when you define local variables, you'll just see final or var without writing the type like string or int. The compiler is smart enough to figure out the type for you just based on the value you assign initially.
Right. So like if I write final user message, hello, I didn't write string, but the compiler knows it's a string.
Exactly.
And it won't let me accidentally try to assign, I don't know, the number 10 to user message later on.
Precisely that. It gives you that nice, concise syntax like you might find in more dynamic languages.
Yeah.
But you don't sacrifice the compiler's rigorous checks. It's still statically typed under the hood.
Okay, that makes sense. It's like the best of both worlds, sort of.
It's an efficiency feature, really, but built on that solid foundation of static checking.
All right, now let's talk about what feels like a real game-changer feature, the one everyone mentions for preventing common crashes. Sound null safety. This feels like a must-have in modern languages, right?
Oh, absolutely critical. The huge problem in older languages, maybe less so now, but historically, was the dreaded null pointer exception or equivalent, that runtime crash because you tried to use a variable that you thought held an object, but it was actually null.
Yeah, seen that far too many times.
Dart pretty much eliminates that entire class of errors by making nullability explicit in the type system itself. So if you look at Dart code, especially class members or function parameters, you'll see the question mark text sometimes. You see, say, string.name. That is a direct signal. It tells the compiler, it tells other developers, hey, this variable might hold a string, or it might be null. It's allowed to be null.
Okay, so the question mark explicitly allows null, and what if it's not there? Like, just string name?
Then that variable cannot be null, ever. If you try to assign null to it, or if the compiler can't guarantee it will have a non-null value before it's used, your program will not compile.
Wow.
It catches the error before it can ever become a runtime crash. It fundamentally shifts those common, annoying, null-related bugs from runtime where they crash your app to compile time, where you fix them before you even ship.
That's a massive win for stability and just developer confidence, I imagine.
Huge win, yeah.
Okay, so we've got type safety, we've got sound null safety, fundamental rules of the language. How does this all come together in the structure of an actual Dart program? Our source material had that neat little example fetching some JSON data.
Right. That example was great because it showed the two main parts you find in pretty much any Dart application.
Yeah.
First, you have the declaration of your data structures, usually classes, like the package class in that example. And second, you have the actual operational logic, the stuff that does things. and that's typically inside the main function.
Let's look at that package class quickly. It had members like name and latest version. Those seemed pretty standard. And then it had that description field, which was nullable, right? Using the dot we just talked about, string.description.
Exactly. And the constructor for that class is also quite illustrative. It showed a pattern you see all the time in Flutter. It took two required arguments, name and latest version, which were positional. You had to provide them in that specific order. But the description was an optional named argument. You could provide it using description, some text, or just leave it out entirely, in which case it would be null because it's type string.
Positional versus named arguments. Okay, that's a key syntax difference.
Getting comfortable with that constructor syntax is really helpful for writing clean Flutter widgets later on.
Makes sense. And then the other half was the main function, the actual execution part.
Yes, main.
Yeah.
Critically important. Every single Dart program, whether it's a tiny command line script or a massive Flutter app, its execution begins in the main function.
That's the entry point.
That's the entry point. And the main function in that example was like a little miniature application itself. You saw how to pull in libraries using import dart.convert. You saw the async keyword being used, which signals that the function might perform asynchronous operations like network calls that don't block execution, and just standard control flow with an if statement to check the results of the fetch. It really shows how the whole thing gets rolling.
Okay, speaking of getting rolling,
Yeah.
let's connect this directly to how a Flutter app starts up. We know main is the entry point, usually in that libmain.dart file. And typically the last line in main is run app, const my app, or something similar. But when should we actually be doing initialization work? Like setting things up before the app UI appears.
Right. This is a crucial point about application flow. There's a time constraint.
Yeah.
If you have initialization work that's really, really fast, like setting up a couple of variables, maybe configuring a simple service locator, things that take less than a fraction of a second, that work must happen before you call run app.
Before run app, okay.
But, and this is the big warning at that specific point, before run app is called, the Flutter framework isn't fully running yet. The widget tree doesn't exist. You don't have access to build context or anything like that. You're basically just in a plain Dart environment at that moment.
Okay, so quick, simple setup before run app. But what if I need to do something slow, like load user preferences from disk or make an initial network call to get configuration data? I can't just put a wait for that before run app, right? Because that would just freeze the app before anything shows up.
Exactly. You absolutely cannot block the main UI thread before run app. Or really, ever, if you can help it. That guarantees a frozen screen and a terrible user experience. For any initialization that takes time loading from disk, network calls, heavy computation, you must handle it asynchronously in a way that does not block the initial rendering.
So the UI has to be allowed to build first.
Yes. The UI needs to show up quickly, maybe showing a loading indicator or some placeholder content. And Dart and Flutter give you great tools for this. Standard asynchronous programming with async and await is the foundation. Then you have things like the Future Builder widget, which is specifically designed to build UI based on the state of a future. It shows one thing while waiting and another when the data arrives. There are also other patterns like deferred loading or just fetching data later when a specific screen needs it. The key principle is don't block the UI thread. Keep things responsive.
That brings up an interesting distinction then. There's setup before the UI exists, before run app, and then there's setup or data fetching that happens after the UI starts building. Where does that latter kind of work typically live?
That's usually where the initState method comes into play.
Yeah.
InitState is a special method that exists inside any stateful widget in Flutter. It gets called exactly once, automatically by the framework, when that stateful widget is first created and inserted into the widget tree.
So after it's part of the visual structure.
Correct. This makes it the perfect place to do setup that depends on the widget being live or needs access to its build context. Things like starting timers or animations specific to that widget, subscribing to streams, or kicking off data fetching that the widget needs to display its content.
Okay, so initState for widget-specific setup once it's in the tree.
Exactly. And there's one golden rule you absolutely must remember when you override initState. The very first line of your custom initState method must be super.initState.
Super.initState first. Why is that?
Because the parent state class might have its own important initialization logic to run. You need to let the framework do its setup work before you add your own. Forgetting super.initState can lead to really weird bugs.
Got it. Super.initState first, always. Okay, finally, let's touch on something crucial for just day-to-day Flutter development efficiency, especially when you're building and tweaking the UI. That's understanding the difference between hot reload and hot restart and how they relate to main and init state.
Yes, this is one of Flutter's killer features, but knowing the difference is key. Hot reload, that's the lightning fast one, usually triggered automatically when you save changes in your IDE. Hot reload injects your new code changes into the running Dart virtual machine, but it tries to preserve the current state of your application. Critically, hot reload does not call main again, and it does not call init state again for existing widgets. It just updates the widget build methods and related code.
So you see UI changes instantly without losing your place in the app or resetting form fields, that kind of thing.
Exactly. It's amazing for rapid UI iteration.
And hot restart.
Hot restart is like hitting the full reset button on your app, but without needing a full rebuild and redeploy. It completely restarts the Dart VM for your application. So it does call main again, and it does call init state again for all the widgets as they get created from scratch.
So if you make changes that affect initial state, or change something fundamental in main, or just want a completely clean slate, you use hot restart.
Precisely. Knowing which one to use when can save you a ton of time and confusion during development and debugging.
Right. And there we have it. That was our deep dive into the absolute essentials of Dart for Flutter devs. You should now have a pretty solid grasp of its core safety features, type safety, null safety, the basic program structure with classes and main, and those critical points about app initialization, init state, and the development cycle with hot reload versus hot restart.
Yeah, we've basically covered the language foundation you need. Our sources really emphasize that once you're comfortable with this level of Dart, you're ready for the next big piece, the next fundamental building block of all Flutter applications. Widgets.
Yes, widgets. That's where things start getting really visual. But before we wrap up for today, let's leave you with a little something to think about building on what we discussed. Given that absolute rule you cannot block the UI thread during startup, how does using a pattern like Future Builder, where the UI renders before the data is ready, fundamentally change how you have to architect your application? Think about how that inversion UI first, data later compares to a more traditional approach, where maybe you'd wait for everything before showing anything. How does that influence your state management, your error handling, your whole app structure?
It's a great question to ponder. It really gets to the heart of asynchronous UI programming. And of course, if you want to see more concrete code examples of everything we discussed, type in, for instance, null safety, constructors, async await. The official Bootstrap into Dart page we looked at is an excellent resource to check out.
Definitely check those out. Thanks for diving deep with us today. We'll see you next time as we start piecing together the UI itself with Flutter's widgets.